Hello, my name is Maxim, and today I want to talk about Goroutines in the Golang. Goroutine allows you to run the code concurrently. Let's start by creating simple Go function. We'll call this hello, and this function will just print some text, something like hello. Now I can run this function here, and once I run the code without the raise flag, I got the result. But if I want to run this in parallel, what can I do? I can add here just go keyword, and now once I run code, nothing happened. Why? Because main function ran this hello in the separate thread and didn't wait for this hello to be executed. So main just start another thread and exit the program. So the simplest way how we can get result is to add the sleep, something like 2 seconds, for example, to wait for this function to be completed. So I run, I've got the result. But this is not the best approach because like you never know how long this function will be executed. It also depends on the hardware. On some hardware it can be like 1 second. On another hardware it can be like 10 seconds. So it's not very convenient to use the time sleep. So that is the better way to use the wait group. So let's start by defining variable wait group, which will be from the package sync wait group. So what wait group allow is to just add to this list, I would say, add go routines and wait until they complete it. So before go routine, I can call wait group add. So this will add like we are waiting for one go routine. And after I need to add wait group wait. So it will wait until this one go routine which we added to the wait group will be completed. But also we need to notify when this go routine is completed by calling wait group done inside of the go routine itself. So now I can run the function and I successfully got result without any time sleep, and like we are not waiting for some calculated amount of seconds. Let's create another example. I'm going to define two functions. One will be called increment. And what this function will do, I will create the global variable increment with value 0. And my function increment would increment this variable. And it will call vg. Sorry, this variable shouldn't be increment, should be counter, because it's the same as function name. So counter and vg done. And I'm going to create another function, is read counter, which will just print the value of the counter. So it will be print line and counter. And again, I need to call vg done. So this time it will be two wait groups. And let me call first the read. And then I would call the increment function. And also I would like to do this in the list because I want to increment this value multiple times. So let's create I equal to the 0, 0. Then I let be less than 100 and I plus plus. And I will just move this code inside of the function. And I'm keeping wait group vg wait outside of the function because I want all of this function to be executed like 100 times in parallel and only wait for them at the end. Because if I will move vg wait here, it will first run this two function that will wait for like another iteration to run it again. But adding it here, it will just run inside of the loop this 100, like 200 functions, because this will be executed 100 times and this one will be executed 100 times in parallel, and I would wait for them only in the end. Now let's run the code. And you see a result is pretty unexpected. There is also Golang has the key called race, and you see it's found 3 races. So why do we have this? Because those functions are executed in parallel and both of them are modifying the counter like at the same time. So we executed in parallel like 100 time increment, and each of them trying to modify this at the same time, and we're doing the same with the reading. So how we can kind of make sure that variable is changed only like how do we want one by one? We can do that by introducing the mutex. And especially we're going to use, you see, we have read-write mutex, we have just mutex. I'm going to use read-write mutex. What allows you to do with the read-write mutex? You can log like this variable counter for read and for write. So if you are logging this for the read, any read function would have access to it. So if you run read counter 100 times, it will not block anything. But it will block for writing. And the same for here for the write log. So it will allow access only to one function to do change at the same time. So how can we do it? Let's add before read function. I'm going to call read log. This is block for read write for reading. And here I can add just mutex log. Let's check description. It's log for writing. So now we logged, but also we need to unlog, because if I will run code, nothing going to happen. Let's unlock it. So here, before VG done, I need to call mutex. Here, this is the increment, so we are using the read write log. So I'm going to call unlock, and for read counter, I'm going to call read unlock. So, and now if I run the code, you see there is no race condition and result printed in the order. So we got what we expect. So thank you for your attention. This is all what I wanted to show you today. Have a nice day.